All right, this is the Geometry Unit 3, Lesson 6 video. This video is all about looking at pairs of lines and looking at their equations, which is something that you covered in your algebra course, and based on their equations, determining whether or not they fall into the categories that we covered at the beginning of this unit. So if you remember, the categories of angles that we covered in the unit were as follows. We had parallel lines, we had perpendicular lines, we had just plain concurrent lines, and we had lines that were the same. We call those coincident lines. So look back into the lesson 1 notes for more information about just what those different categories are. But I am going to talk about how, like I said in this lesson, how we determine each of these categories when we're looking at the two equations. And what I mean is this. If I get the equation of two lines what can I use in these equations to determine any of these possibilities? And so I'm going to walk through examples of each one of these possibilities and talk about how we know which category a pair of lines is going to fall under. So when we do this, we're going to take a particular approach. The first thing we need to look at is the slope. And that's actually the main thing we need to look at. So if the slope of the first line is equal to the slope of the second line, it's either parallel or coincident. It's got to be one of those. So I'm actually going to move those together. Let me drag this guy over here. Let's drag him down here. Let's drag coincident down. Let me fix this writing so this is a little bit more understandable. And we have parallel right here. That's not going to work. There we go. All right. So parallel and coincident both have equal slopes. That's what these two things mean. So I'm going to write that. So they both have equal slope. That's what this means here and here. So if they have one of those, you know that it's got to be either parallel or coincident. But the thing is, if you look at the y-intercept, the y-intercept of parallel lines will be different. And the y-intercept of coincident lines will be the same. So what I'm telling you is that if everything about the equations is the same, then the lines are coincident. That should make sense because those lines are the same. Whereas parallel lines go at the same angle, which is why the slopes are the same, but the y-intercepts are going to be different. So for example, if I said that we have these two lines, y equals 4x minus 3 and y equals 4x plus 2. I look at these two lines, I see that the slope of this line is 4 and the y-intercept is negative 3, and the slope of this line is 4 and the y-intercept is 2. So we can see that the y-intercepts are the same, but the slopes are the same, but the y-intercepts are different. And we know, based on what we just got done talking about, that when that happens, that means these are going to be parallel lines. So these are going to be parallel. So because they have the same slope but different y-intercepts, they are parallel. Now, what about perpendicular? Well, as you've seen here, anytime the slopes are the same, it's going to be one of these two options. Well, when it's perpendicular, you're going to have a different situation. Let me get this all sorted here. Move that over there. Let's move this over here. So for perpendicular lines, you write this down. The slope is different. But more specifically, if I multiply slope 1 times slope 2, it equals -1. That's kind of your key piece of information right there. So, and then if none of these three meet any of the, if the line does not meet any of these requirements, then we know that we have a concurrent line. So concurrent pair. So I'm going to write over here all others. So you have four possibilities. You have the slopes are the same, and then you choose between parallel and coincident based on the y-intercept. Then if that is not true, then you go look at the slopes. If they multiply to make -1, then it's perpendicular. Any other option goes under concurrent. So let's look at a few other examples. So let's say I have the following. Y equals 1/2 x plus 3, and y equals -2x plus 7. So let's identify the slope and the y-intercept of each of these lines. And you'll want to do this every time, and the lesson asks you to give this information. So the slope is 1/2 here, the slope is -2 here, the y-intercept is 3, and the y-intercept is 7. So we notice that they are different. So now, if they're different slopes, we automatically know we need to check for perpendicular. And then if that's not true, we're going to put it under concurrent. So we take the slope of the first line, and we take the slope of the second line, and we multiply those together. Well, -2 is the same as -2/1. So then we know that the 2's are going to cancel, leaving me with 1 and -1. 1 times -1 is -1. So this means that they are perpendicular. Because the slopes multiplied to make -1. All right, let's look at another example over here. Let's say I have the following. Y equals 3x minus 7, plus 7 rather, and y equals 3x minus 1. We need to identify the m and the b. Well, in my first pair of lines, or my first line, I have a slope of 3 and a y-intercept of 7. Here I have a slope of 3 and a y-intercept of -1. So the slopes are the same. So it's got to be either, scrolling up, parallel or coincident. And since the y-intercepts are different, right here, same slope, different y-intercept, that means parallel. All right, so unfortunately, one of the things that happens is they don't always give us our equations kind of ready to go. So let me show you another example where the equations are not set up. So I'd be like this, 3x plus 4y equals 12, and y equals negative 3/4 x plus 8. Okay, well, you can see equation number 1 here is not set up in y equals form. But this one already we can see has a slope of negative 3/4 and a b of 8. But this other first one we're going to need to rearrange. And if you remember, the first thing we're going to do is going to move the x across. And then we're going to divide by 4, giving me y equals negative 3/4 x plus 3. And so in this line, I have a slope of negative 3/4 and a b of 3. And so looking at these two, I see they have the same slope, different y-intercept. So then that's going to be parallel as well. All right. Here's another example. What if we had 2y equals 6x plus 4 and y minus 3x equals 2? So neither of these equations are ready to go. So we'll start with this first one. We've already got the x in the right place. So I'm going to divide everything by 2, leaving me with y equals 6 divided by 2 is 3x. 4 divided by 2 is 2. And then over here, I need to add 3x to both sides, leaving me with y equals 3x plus 2. I can see I have a slope of 3 and a y-intercept of 2, and then a slope of 3 and a y-intercept of 2. And since it's same on both, so same slope, same y-intercept, these are going to be coincident. And then let's do one more example. Let's say I have the following. Y equals negative 2/3 x plus 7, and y equals 3/2 x minus 4. Okay, so looking at this, I have an m of negative 2/3 and a b of 7. And over here I have an m of 3/2 and a b of negative 4. So the slopes are different. I run up here and I see that when the slopes are different, I need to test to see if they fall into the perpendicular category. So I'm going to multiply the slopes. So I'm going to multiply negative 2/3 times 3/2. And you should see pretty quickly what's going to happen. The 2's and the 3's are going to cancel out, leaving me with negative 1. And so that means perpendicular. And so again, if that didn't work out to negative 1, I would have concurrent. And so this is what you're doing. I can show you on the lesson down at the bottom here. They give you two lines. You need to identify the slope and the y-intercept for each line. And then you need to identify which category it falls under. They're at the bottom: parallel, perpendicular, coincident, or concurrent, based on that information. And that is it for lesson 6. Next week we'll have a review and we'll be testing as well.